Let's give a warm welcome to Mr. Srinivas Badam, a seasoned professional with a remarkable trajectory within Tata ecosystem. Starting as a graduate engineer trainee at Tata Motors, he leveraged his skills in rising the ladder and ascended to divisional manager, showcasing unparalleled dedication. With professional experience in managing diverse range of plant activities, Mr. Srinivas is currently serving as Senior General Manager, Head of Operations in Electric Vehicle Battery Division at Tata AUTOCOMP. Today, Mr. Srinivas will discuss laser technology for battery pack manufacturing. Please welcome Mr. Srinivas.
Before I go to the advancement, a few slides on the understanding of what is a laser basically. If you a laser is created like when the electrons in the atoms, like glass crystal, absorb any energy from electrical current or light. So the photons are interacted in three ways. So if you see at the bottom side, for each change in the energy state from low energy to the high energy, or from the high energy to the low energy state, a photon is emitted. So basically, this process is leads to the increase in the light output, and is the reason for the name of laser, which means like light amplification by stimulated emission of radiation. So we need to know that how this, like just to give an insight of what is a laser, what we mean by. So mainly these are the two lens which are very much important in a laser. So there are basically two components which I see. Uh, one is uh, one is for a laser generator and other is called as a laser head. As we see here, these are the two specific important lens which are the collimating lens and focusing lens. So these are the two lens which are used for you know getting onto the right point of welding requirement. So collimating lens is basically used to convert the divergent light into parallel beams, and these are the focusing, which are then sent to the focusing lens. And focusing lens, as we understand, it's a main role to focus the laser beam to the specific focal length, and depending on the application, it is where the point of application of welding is to be done. The focusing length positioning is decided. So if you see these two slides, one is what is a laser and what are the specific parts in the laser. As I said, laser head and laser generator. So just to give an insight on the more just to start with what is the laser welding process. So I will just read out because it's each statement carries each word carries an importance to this. So basically, it's a welding technique to join pieces of metal or by using of laser. The beam provides a concentrated heat source, which allows the narrow deep welds and high welding rates. So basically, there are two types of welding. One is a keyhole and a penetration mode. Keyhole or a penetration or a conduction welding. So basically, what it means, like, what is the importance of this laser welding? As you see on the right side, I'll try to explain here. Uh, these are the crystals. So these crystals are energized by a power supply to generate the photons, and this is wherein this the photons are generated, and this collimating lens, which is allowing to parallel of the beams, and then this is a focusing lens, and this is a weld area. So this is on the basic of what is a laser, basically a welding or a laser beam generator, what it is. So the spot size of a laser can vary. I'm specifically talking in terms of industry for the battery, that is 0.2 mm to 13 mm. Depth of penetration is, as we understand, depth of penetration is to the amount of power supplied, but is also dependent on the location of the focal point. Very, very important point. So if you see that there are two aspects, the power and the focal length, the focal point. So there are again two types in this. One is a continuous laser welding and the pulse laser welding machine. So I will explain you what happens in the battery industry in the next upcoming slides. But to make this understand, there are two types of applications which are depending on the thickness of the parts which are getting welded. That decides that which type of welding we have to use. Either it should be a continuous or a pulse laser welding. So the speed of welding is also proportional to the amount of power supplied, but also depends on the type and thickness of the work pieces. So this is on the basics of the laser welding process. So as I said, on the components of the laser welding machine, so we have like one is a laser generator, the second is a laser held, and the laser weld monitor. So nowadays, this laser welding is very much important application. If you remember, like in the old past days, I hope we have some bit understanding on the battery packs, like in like the Tesla battery packs or some old battery packs wherein all the cells are connected with each other to because there are so many cells that are used inside the one battery pack. There are around 100 of cells that are used. So to connect all those battery pack, those all cells with each other, there is a process. The original process was a nut bolt process where some issues we were used to face on the tightening methods, or the because of the tightening methods, there was some issues of the loose contacts, and these loose contacts used to get generated heat and maybe a thermal issues for the in the field also. These are one of the critical aspects, which is then the technology changed from this tightening process to a welding process. A lot of things have got involved in this laser welding. So the latest and upcoming, the latest technology that what we are using is of the mainly for the laser generator and the laser head, which is used for the connection of the cells with each other. So that required power and energy is uh, which is outcome of the manufacturing. So so as I said, there are two types. One is a conduction welding and a keyhole welding. On the conduction welding, you see it's very clear to understand that wherever there is no need of penetration, or where are some applications where the penetration is not needed, then only the surface welding is needed. That areas we go for a conduction limited welding. Whereas keyhole laser welding, so it's a bit explanatory also. So wherein the like using the high power densities by keyhole, wherein the power density is around more than greater than 106 to 107 watt per centimeter square. So it's basically a keyhole means to have a better strength. It's mainly to give a right strength. So what are the advantage and why this laser welding is used? So first is definitely to understand that the welding results are very important. As I said, in the batteries or in the cells, there has to be a good contact between the cells which are connected to each other. So the contact has to be really 100% in the vibration, in the travel time. There in the vibrations, the welding should not go off, or the bolt should not get loose enough. So because of that, the welding is strength is very important. So the laser welding is one of the best method to ensure that we get a right welding quality. So as we see here, the laser weld is narrow with an excellent depth to width ratio and higher strength. So, and also definitely there are other benefits of this on the productivity and the precision work. And these are the other benefits that we get when the welding processes are done either by on its own, because these laser welding are uh, it's not by a manual process. It's definitely a machine systems are always there. There are some servo control systems are always there. The positioning is decided by a camera detection system, so that the positioning of the welding is decided, and the welding is done at a required point. That is the most critical aspect in the when we are dealing with the laser welding. So, so basically, see, as we know that there are some advantages in the laser welding, uh, like we saw that the welding strength, we get a good welding strength. The precision of the welding strength is clear. The hole sizes can be defined because these are all small size cells. This is 18 dia, and actually the weld area will be not more than 2 or 3 So the precision of the welding is very important. So as I said, it's like 0.3 or 3 zero 0.3 to 12 is a welding dia that can be happened. So but there are some other areas that needs to be also look at it on the energy or on the laser part. So like a spatter, because when there is a welding process, always there are areas of concern that the welding spatter comes out. So this welding spatter is definitely a big area for concern whenever we are in the field of battery pack manufacturing. So this, how it can be controlled by controlling the energy density or the power requirements. We can control this by adjusting the focal length. So these are some of the critical parameters depending on what type of material we are using, like copper to copper or copper to stainless steel. There is no any defined uh, calculation as such, because the thickness of metals also decide what is the power density that we require, what is that, how much dia of the welding is required, is it a continuous laser welding, is it a pulse laser welding that is required. So there are many things to this. So, and also always in the welding process, the nitrogen purging is a must, so that the oxidation doesn't occur, because at the welding process. And definitely at the welding process, the basic requirements are like the gaps between the two plates welding has to be really zero. The surfaces of the welding has to be really neat and clean. No dust has to be there. So these all things also matters a lot. So there is a definite good control process is required at the time when we are going for a welding process. But yes, the advantages are so strong that it can hold it for years and years, maybe for 10 to 12 years also. That is the advantage, and that is what is the cycle life expected in the field also. So there are, like I said, in the laser, there are again, when we talk about a keyhole type of welding. So in this, one of the developmental, because this is one of the technology, but there are many things to next technology that is coming is now this is a single mode laser. Now, as I go to the next slide, in the single mode laser, there is an issue, or there is an area for concern where we see as a spatter. You see on the screen, there are some spatters that get generated because of the single mode laser. So on this, actually, there is already a solution in place in the market, where is the multi-mode laser. As we see the central beam and the outer ring, the ring beam. So basically, there are two beams which are done for the welding. So whatever the single mode laser welding is done, the penetration depth is achieved by the single mode laser. Penetration depth is also achieved by the multi-mode laser, but the advantage that what we have here is like the spatter, whatever is getting generated at the time of welding, gets molten on the spot itself, so that it doesn't allow to, splash out in the remaining other areas. That is a very good advantage, and that is a new technology that has come into the welding process. So some of the critical aspects when we are in like into the manufacturing stage or in the manufacturing process, because it's a thousands of welds happens in a maybe in a one battery pack, something like that. So maybe in lakhs of where welds are being happen, and it's a real time. So it's a fastest technology and it's a latest technology, but at the same time there is a need to understand the weld strength, which is a continuous process, because at each weld point there is a need to check on the weld strength. So there are many innovations has been done in the weld monitoring system, like which is one of this is a inline weld monitor, wherein at the time of a laser beam itself, there is a process to check the laser depthness. That is a LDD, what is called as a laser depth detection system, which is also an inline weld monitor. So wherein the inline, wherein like we understand, this is one of the critical parameter, or which is a critical process. That is what is to understand on the inline weld monitor. So as we see here, some advantages on the inline weld monitor is the online quality inspection. That is what we very much important in the welding system. So if any weld mess are there, some errors are there, some offsets are there. So few more things like to understand. In the battery industry, it is used for lithium-ion battery manufacturers, flexible and method to easier. So in the laser, this is what is I would like to emphasize that this particular technology is really helping to get on to the right quality, and also to the productivity matters. So these are the big advantages wherein like that, and definitely the precision is the most important. So because the handling of these cells are so small, that when there is a welding operation, so we have to be more precise. So overall, as we see here, the battery industry is growing, and in this battery industry, laser welding technology is becoming a very key role to ensure these all things in place.
Thank you, Mr. Srinivas, for
Yeah.
discussing laser technology for battery pack manufacturing.